Projecting sequence diagram or UML from SBC process algebra. I'm Dr. William S. Chow. Chapter 1 SBC process algebra is a meta or model or UML. We use SBC process algebra to ensure consistency between UML different diagrams. Because SBC process algebra is a meta model or UML, so sequence diagram can be projected from SBC process algebra. That would say sequence diagram actually is a projected view of the SBC process or a system. Chapter 2 introduces SBC process algebra. SBC stands for Structural Behavior Correlations. That is, SBC process algebra is the only formal language which is able to integrate the structure and behavior of a system. Since SBC process algebra is a formal language, we now talk about its entities part and its syntax and its semantics. SBC process algebra uses many entities such as operational code or operational return formula and other entities such and such. We use an operational formula to describe an operation. There are two kinds of interaction in SBC process algebra. Type 1 interaction is an interaction between an actor and the COE object. Type 2 interaction is an interaction between the caller object and the COE object. SBC process algebra uses 3 BNF rules to describe the syntax of the language. With the syntax description of SBC process algebra, a system is then modeled as many summation of IFD, and each IFD is represented as G11 prefix, A12 prefix, A13 prefix, such and the prefix stop expression. SBC process algebra uses the transition rule to describe the semantics of the language. For example, the prefix transition rule and the summation transition rules. With the transition rule, we then have the transition graph of a system, as shown here. With the transition rule, we also can have the transition graph of an IFD, as shown here. A transition graph is described by the transition relation T with 3 attributes. With further extension, we can have the transition relation as T relation with 6 attributes. We now have the summary of SBC process algebra. The transition graph is a single and only one diagram that SBC process algebra used to describe the semantics of an IFD. Now let's go to the final chapter. Chapter 3 describes how to project a system sequence diagram from SBC process algebra. An IFD transition graph is described by the relation IFD with 6 attributes. In UML, a system has many IFD, and each IFD sequence diagram is shown as in this figure. An IFD sequence diagram is described by the interaction relation sequence diagram IFD with 4 attributes. Now let's talk about the projection algorithm. Because in the UML modeling, there will be 1 to n IFD. Therefore, we will have 1 to n looping. For each looping, we will have 2 steps. The first step is to create a new relation, sequence D, with 5 attributes. The second step, we will insert new record into this sequence diagram relation by selecting 4 attributes from the IFD relation. And each IFD relation will have 6 attributes. Thank you for your listening. Bye-bye.